Yay. Thank you. I'll be here all day. All right, so they wanted a controversy, I can never remember which way around it is here, right? And I am known as the sort of like the Cassandra of programming. And so probably my most famous talk is the Agile is dead. So I suspect they wanted something like OTP is dead. And in fact, I even came up with like kind of a cool kind of like concept logo, nOTP. But no, I'm not going to do that. I refuse to be buttonholed and pigeonholed into this idea of being so negative. I love OTP. There we go. I got the first kitten picture in, therefore I win. I love OTP, but just not all the time. All right? And what I want to convince you to do is also to consider whether or not OTP is always the best solution for what you're doing. Let's talk with a little definition. Because really, OTP is a totally meaningless concept, right? Everybody talks about OTP, no one's actually said what it means. So for me, OTP is simply the conventions, libraries, and tooling used by Gen X. Yeah? Isn't that cool? But yeah, like so, if you're writing Gen servers or whatever else, then you're using OTP. That's my definition of it, so let's stick with that. So, OTP history. You all know the history of OTP. OTP came along because Ericsson needed software for telephone exchanges. One of the things they needed was reliability. And we all know that Erlang has something like 107 nines availability, right? It's like, it can't be measured because the universe will end before an OTP application crashes, et cetera, right? It's an incredibly reliable environment. That's fantastic. But think about it. If you put software into a telephone exchange, it's not the same as software running up in the cloud somewhere. This is embedded software. This is the same as software that runs in a washing machine. It's shipped out with physical hardware, and it runs who knows where. So this thing has to be largely self-managing. You're not going to have developers SSHing into a telephone exchange to find out what's going on. Another nature of the beast is it's repetitive. There may be 10,000 switches or 100,000 switches in an exchange, and in the Erlang sense, that's going to be 100,000 identical processes running, or n copies of, running to manage that switch. And that's kind of like reflected in OTP. It's a highly controlled environment. No one is going to say, hey, I wonder what happens if we add 1 to this variable. Let's try it and see. This is one of these environments where changes go through committees and sign-offs and everything else because it's life critical. You get that wrong, and people can literally die. It's a very important, very responsible activity, writing software like this. And OTP is great at that. Now, how do they do that? Well, first of all, OTP is very static. It has a static architecture. It has a static configuration. I'll talk about that in a minute. But as you know, you basically configure things at compile time, both the way architecture works and the way configuration works. We tend to create monolithic applications because that's what it's designed for. It's designed to ship a bunch of software into a bunch of hardware that then gets put in a crate and sent to a telephone exchange. So we write our Erlang programs, our Elixir programs, as big monolithic hunks that we ship out. It's not designed for large scale, or more to the point, it's not designed for distributed large scale. It's designed to run on a backplane. And in fact, Erlang will struggle at, numbers vary, but maybe 100 or so dispersed nodes. The amount of chatter that goes back and forth between the nodes gets to the point where it actually becomes a problem. It is also slower than it could be. There's a sweet spot. If you run an Erlang or an Elixir program and there's not enough load going into it, it's going to run slow, typically. If there's too much load going into it, it's going to run slow. You have to give it the right kind of balance of load if you're going to get performance out of it and actually get the parallelism that you want. And I'll get onto why in just a minute. Now, I don't think that that is particularly bad. In fact, I think it's really good if you're writing that kind of software. If you're writing software which is going to become embedded, is not going to change that often, then this is a really, really great architecture to be using. But it can be bad. It can get in your way. Because who here is writing applications which are designed once, stick into some hardware, and then get shipped? But you're still writing code as if you were. The world has changed. We have a new world, we have new challenges. It's a dynamic world. It's a world that's changing all the time. Not just in terms of like the technologies, but also just the simple requirements that we're expected to meet day by day. It's a world of confederation, where things are talking to things that are nothing to do with you, where we have to be able to handle all of these weird interfaces and weird conversations our software is supposed to have. It's a world that lives not on a backplane, but on a global plane. It lives in the cloud. It's a world of serverless applications. It's a dispersed world. We're living in a world that's rapidly changing to become massively scaled. I read a thing in the CACM last month that said less than 1% of the processors, I think it was in Europe, but I suspect this is true for the world, less than 1% of processors actually have some kind of human interface, like they're running in your computer or they're running in your cell phone. 99+% are embedded, and that's only going to increase. I've been saying for years the browser is dead, and one day, please God, that will be true. Because increasingly we're interacting with computers without interacting with computers. We interact with our computers when we're driving a car. And computers are doing all sorts of things for us without us even knowing necessarily. That is the world that we're moving into. And that's the world we're going to need to be able to address. And then last, it's a world where, in the Erlang world originally, if you were writing this code, you were dedicated to writing this code. Now that's not true. We have to wear many hats. And so we have to make it easier for people to come in, write code, move out, do something else. So, boring metaphor, but OTP is a tool, and it is very good for doing one particular thing. It is not particularly good for doing other things. I put the rabbit in there as a bit of a joke, right? Bang, 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 squish, right? And then I realized rabbit MQ is actually written in OTP, so that's got to go, sorry. Anyway, so this is my slide of hope. Okay, this is my inspiration. This should have like some corny thing going across the top of it, Every day is a new day, or something, I don't know. But this is my slide of hope because I'm about to get into the way I really wish the world could be. These are things I would like to see different. Supervision, okay? It's a fundamental concept in OTP. And it is, by and large, misunderstood. Bruce Tate, James Gray are talking about this in their new book, and they don't call it supervision, they call it lifecycle management, which is actually a way, way better term for it, because that's what it does. It manages the life cycle of things. I want us to see us move supervision out of the main body of code. It is totally orthogonal to the application. We should not be writing supervisors in the same code base that we're using to write our application functionality. So I want to see us extract it out. I want to see it dynamic. I want to see everything become dynamic. I want to see us be able to specify some kind of new supervision thing, add new processes or whatever it might be, and have some kind of mystical three-wave diff take place that then brings the system up to date with our requirement of our supervision tree. I want to have supervision have a nice management UI. Because when you think about it, this is how you want to be able to monitor your application and also be able to do things like, oh yeah, I need to bring on a new processor here or whatever it might be. And last but by no means least, why do we supervise processes but not everything else? Because as far as I know, nodes and servers and clusters can also go down. They also need to be brought up. They also need to be restarted every now and then. Why don't we have one tool to supervise them all? One change. Configuration. Let's be diplomatic. The configuration mechanism in Elixir and Erlang sucks. And it sucks because it's designed for telephone exchanges. It is 100% static. I want to move all of our configuration, I want to move 90% of our configuration to runtime. But not just by making some kind of module called config that has functions in it. I want to see us move towards the idea of having configuration servers. So that when our applications start up, they go and get their configuration from a server. Because if we do that, then we can also have the concept of config change events, which means that if somebody changes the configuration, our application will be able to update itself while it is running. You want to move to a different database? Fine. Enter the new parameters, config changed. At the end of the current transaction, we switch across. That's the kind of thing that's possible if we move to server-based. And if we have server-based, we can also then have a UI for it. So we can have a look at our configuration. We can change it using decent tools. Just a thought. And I want to see our configuration properly hierarchical. I want to see it per process, component, server, cluster, application, and possibly even global, say within a company. And have proper inheritance so that it all just works. It's a world of federation, not of monolithic blocks. So, first of all, this word application, I talked about this last year, right? Application is a really bad name, let's forget it. Instead, an application is a federation of components, and it's configurable at runtime. Again, it's dynamic. So, we're no longer going to write monoliths, we're going to have lots of things that cooperate to do something. This tells the time, for example. And we're going to have these components that could be shared between applications. Again, the sharing can be configured at runtime. I want to talk about scale and speed. Kees de Groot said that Erlang was developed for these local backplane, local area networks, high-speed buses. We need to look at way more modern discovery and synchronization mechanisms than EPMD. We need ways of configuring 10,000 Erlang nodes together. Because at some point, we're going to need to do that, or someone else will. We need to have better ways of syncing things. And we definitely need support for load management. Again, if we're going to look to scale, we have to do this. And then last, and this is the one that's going to, I think, upset people the most. When we write Erlang code, 99% of us are actually writing Ruby, or Java, or whatever other insult I can throw at you. Because what we're writing is synchronous code. When we're writing function calls, they're all synchronous, but when we're writing OTP, I haven't got the stats, but my guess is it's something in the 90 plus range of those calls they're calls. They're synchronous. They send a message, wait for the response. And that's why I say there's a sweet spot in terms of getting the most out of a processor. Because if you're only doing one thing in an Elixir app, and that thing is doing calls, then your processors are sitting idle most of the time, right? If you have a 10 processor or 10 core machine, and you have that application, only one of those 10 cores is doing anything. So I would love to see us move away from call. I would love to see cast being the default. And the thing is, we actually have mechanisms to do that. The other reason to look at using these asynchronous things is that's what the world is. The world is asynchronous events. Programs, their entire job is to juggle these incoming events. So why don't we live in that world? I have just spent a long time over the last couple of weeks trying to convert incoming events into an Elixir stream structure. And it sucks. It's really hard to do it nicely. It should be the most easy thing on the planet to do that. That's what everybody needs. The world is asynchronous. We need to live with that. In fact, we actually need to live within that. Because what we want to see is our data and our events just flowing through streams of pipes, of functions, right? And there is this religion in the Elixir world about back pressure, about flow control, about not losing events. Bullshit. In the real world, you just shrug and move on. Because you cannot tell the real world to stop because my logger is busy. That just doesn't work. So we need to throw that all away. We need to think, how do we write applications that perform well, that actually can handle overload conditions gracefully, as opposed to sulking and hoping everybody else just slows down because I can't cope, right? That's ridiculous. So let's think about the opposite. Let's switch to cast, not call, become asynchronous, and then work out how to deal with the consequences. Now, what people will say is, but Dave, we can already do this with OTP. To which I say, of course we can, but we don't. And we don't because there's this kind of religion that says, this is how we do things around here. And that's a really established religion. Breaking that is going to be difficult. And breaking that is going to happen from the outside in. It's going to happen because we choose to write our applications in a slightly different way. And because we will be successful doing it. I severely hope, no, I know that the future of the Beam is not serving web pages. A, that is boring. But B, that's not where the action is. And that's not what we're particularly good at. The benefits that we bring to this are, incredibly high concurrency, incredibly high connectivity, right? The ability to have these streams of events going on all over the place. That is not web programming. The future of the Beam is connecting the world. The future of the Beam is building this new world. And we, as a community here, are in an incredibly strong position to be able to do that. We can create a new world. But to do that, we're going to have to push the old aside just a little bit in order to get it to work. So now I'm going to get beaten up by Brian. Thank you. Do you want slides or?
No, I'm good. Can you hear me? Okay.
Good. Keep it that way. It's good.
There we go. You know, it was funny. I was standing over here, and then I got some alerts, and I was looking. Like, I got these tweets. Some guy named Dave Thomas was tweeting at me and talking about language features in a community, abusing it. But the funny thing was, well, I saw Dave Thomas up on stage. Who could this be? Apparently, there's another Dave Thomas in the F# community who was responding to some F# features and the way the community was abusing or misusing those features. I guess people named Dave Thomas tend to pick up this role. So
it's a clone.
Yeah, exactly. I'm gonna set this down. Okay, so yeah, I took some notes. I didn't see the slide deck itself ahead of time, but we did have some discussion. So some of it's a surprise, some of it's not. I'll try and keep this short because what we'll want to do is, open this up to some discussion with the audience rather than just give two perspectives and just call it a day. So at the core of this, I think one really interesting point is that we're asking some really important questions. And I don't think Dave or I would ever disagree that these questions are not worth asking. This is a really interesting and important conversation. The interesting thing is I think our responses to those questions differ quite a bit. And sure, we can talk about what OTP is and which parts of it are useful for our little application, but the interesting thing is how we got to this place. Why are we all here? At this conference today, we're here to experience great content from a lot of people in the community. We're here to learn. We're here to extend our craft and get better at how we write the software we do. And the way we do that is we all share some kind of value in what makes Elixir the right language for what we're doing, what makes the things we see in the community great. And a lot of these things are borrowed from existing inspirations. So for example, Ruby comes up a lot. What does Elixir borrow from Ruby? Well, we could talk about technical things, but it also borrows a lot in terms of value, what we look at in terms of code and quality. But Elixir is also the intersection with Erlang. And so when you hear things like reliability, scalability, uptime, those sorts of things, you might think, well, that really only applied to those telephone switches. I don't really think that's true. Everyone is constantly looking for better ways to make their software, better ways to deliver something that accomplishes whatever their goal is. And saying that, no, we shouldn't really stress over all of these things isn't really the right approach to the conversation, in my opinion. What we need to see is that we have some contention between these two communities in the values that are upheld. Elixir borrows certain things like being explicit from the Erlang community, and you see that every day in the way the APIs feel and look. And sometimes that's at odds with some things that we want to make easy or even fun in the language, borrowed from the values that we gain from Ruby. And so really, looking at OTP, we might say, well, there are issues with configuration, clustering, supervision. Does OTP force a static structure? And the answer here is that OTP is actually a living, evolving thing. It seems like 30 years have passed and it's still kind of the same thing that it was, but what has been amazing is with the rise of Elixir, Erlang has changed. It started putting motion into the language. It felt like Erlang was at a local maximum. And now with the extra energy of this new community, it's pushed it out of that rut, and it's starting to move again. It took a while. And so I think the invitation should really be that we look at how we can evolve OTP. And we see things like the Erlang Ecosystem Foundation giving the community a voice and a way to interact with the design and evolution. It seems like a really great idea to find the right working groups for these sorts of topics, rather than sort of set it as do or don't use OTP. I'm almost certain we have more control today than we ever have over where things go and how things work and look and what we make better. So for example, we had application configuration. There's a lot of things going on there. I'm not really going to say whether or not things are entirely great or bad, but things like saying it's entirely static aren't necessarily true. The application environment and things like that are actually running through services and code and this OTP runtime, things that are actually not static. It just doesn't provide ways for you to say, oh, I want to update the configuration and persist that value. Or the way your application might boot might not have a clear place to just sort of slot in, I do need to query some external system as I'm starting up. Those things are not hard to accomplish. I've seen them in libraries and other parts of the ecosystem that date back to 8+ years ago, so I know they're there. We just need to start finding ways to make these things common, make these things easy. Likewise, there are new initiatives that already exist. So for example, clustering and registering things dynamically, the visibility of nodes and configuring those, handling IoT scale sorts of deployments. Things like partisan are really exciting. They actually solve a lot of these problems. We talk about the distribution in Erlang sort of being almost magical, but then falling down like around 100, 200, 300 nodes. Depends who you ask. I've seen it go larger, but it's tricky, right? We see things with supervision trees and boundaries of like, well, why does my application have the supervision tree rather than sort of the deployment environment? Why is this part of my code rather than part of my deployed environment? And this is really important. I think one unique thing that is hard to get right is concurrency in a language is more than just a programming feature. It actually has a lot to do with the operational characteristics of your software. So if you want to write a system that works a certain way, and then suddenly, you want to optimize a hot path in there, you may need to, add some caching or some sort of stateful thing. But that cache needs to be instantiated before your other thing starts doing work, so it actually calls into something that exists and actually has a cache to hit, so you're not trying to use something with another thing that's not there yet. That sort of initialization process is sort of an internal concern of the thing you've just built. And breaking that out can create a lot of unintended modularity problems. It can actually make coupling worse in some cases where, sort of the straight line logical thinking might seem that it could be more modular if we make this runtime configurable. But the concurrency side effect here is that there are way too many ways things can go wrong if you don't have these known states and controlled boot environments. And so while Erlang feels static, that's exactly what makes a lot of the concurrency primitives actually work. And so where we give it up is something that needs to be considered carefully. So those are some of my notes. I don't really want to keep talking about technical things, especially with slides. Yeah.
So for what it's worth, I don't disagree with you. Mostly. And I think that it's interesting that you say that the Erlang community is changing partly in response to Elixir, which I think is probably true. But what I'm seeing is the Elixir community is actually not. And the Elixir community, I think, has this kind of like slight, I don't know what the word is. It's not inferiority complex, but it's kind of like being afraid of upsetting Big Brother or something, right? And so we have to do things the Erlang way. And the excuse that's used is often, well, it's so complicated, and people have spent 30 years thinking about this, and therefore, there must be a good reason for it, so we'll do it that way. All right? That's the old, that ain't the way we do things around here, boy, argument, right? And I think if the Erlang community is recognizing that actually, we needed to change, then maybe we should be slightly less reverent of adopting the older ways that the Erlang community did things. A conversation I had with Joe Armstrong last year, about OTP and GenServer and stuff, is he was like, oh, I don't use this GenServer stuff much. Yeah, I just typically just code up what I need and do it that way. So I think, yes, I agree with you that Erlang is changing. I think the problem, though, is not necessarily on the Erlang side. I think the problem is that the Elixir side is tending to ossify around some of the older Erlang ways of doing things.
Okay, so this is obviously a little chaotic. It's the first time we've done anything like this before, so please bear with us. But what we're going to do, and actually let me explain what we're doing here. If I can. When we were looking at what to do for the next MPEX, we wanted to do something experimental and kind of try to push it forward. And one of the things that you hear from people who go to conferences, I mean, why would you go to a conference when all of the content's going to be available online for free anyway, right? And everybody's, the hallway track. The hallway track is the important reason to go to a conference. And that's what you really get out of it. That's what you get out of being there in person. I don't know if you've noticed, but we don't have any hallways. So it puts us at a major disadvantage. So we decided, well, hell, let's bring the hallway track into the event itself, and that's our intention today. So can we have the house lights up, please?
Whoa, there's an audience.
I could see y'all.
Oh, there's people.
Yeah, there's people watching us.
I didn't know that.
Okay, so I'm going to try to moderate this discussion, and I'm going to try to bring you guys in. We've added some chairs up here, and this is the intention of this is if anybody who wants to participate in this panel discussion can feel free to just come to the front of the stage, and I'll kind of manage bringing you aboard. Obviously, we have limited space, so
if we don't get volunteers, we're going to go grab people.
Yeah, we'll get some Army volunteers. Don't worry. Let me kick it off. First of all, one thing that Dave said that I thought was interesting, and I think probably true, is that 90% of the time people are using call rather than cast. So I'm going to ask a couple of questions. First of all, how many of you have actually written gen servers? Right, so lots and lots and lots of you. All right, how many of you agree that you're using call 90% of the time over cast? In other words, you're synchronous 90% of the time. Ah, interesting. How many of you think it's maybe 50-50? A few more.
Wow.
That is interesting. How many people would say that you're using cast more frequently than call? All right, can we get microphones over there? Right here.
Could you report what you see?
Sorry,
Yeah.
it was about
Hello?
It was about maybe a third were in agreement with Dave, maybe a third disagreeing, and there's like about 10% are falling at the other side. So, okay, so you, sir.
Yes.
Explain yourself. Like you
Way to make the audience feel comfortable. Good job.
tell me how is it that what challenges that you run into and sort of like how is it that you're operating that way?
Trying to focus a lot on getting processes to, I guess, embracing being async. The idea that something might not be ready right away, or that some parts of the system are unpredictable, is sort of baked into how you build these applications. So the app that we're working on has a lot of calls to external processes on the system, sometimes network calls, and call me when you're ready, and if not, after some threshold, explode violently.
I see. Very good. What sort of application is it? Is it a web app?
Yes, sort of. Is this the time to plug? Do I plug now? Yeah, we build a online IDE backed by Elixir that shells out to Docker containers and provides environments for students at the Flatiron School.
Gotcha. And I guess the question that I would have is, actually, why don't you come on up?
Oh dear. That escalated quickly.
your name?
Steven.
Steven Nunez. Here we are.
Wait, am I the only one sitting? Is that how that works?
What's that?
Am I the only one sitting?
Yeah,
I can sit.
Yeah, you sit down. We're going to beat you up.
Okay.
Everybody sit down except for me. All right.
Bring on the waterboarding.
This is totally working for real. Okay, so you're actually doing it 90% of the time. Now the question I would have for you, Dave, is how is that possible? Are you using GenServer? Are you using OTP?
Yes, lots. Even to the point of like upgrading live systems, like all in.
So do you consider this to be a refutation of your thesis?
No, I consider this to be a shining star of hope in amongst a sea of darkness, right? Here is somebody doing it the way I think it should be done.
But using OTP to do so.
I never said don't use OTP.
Okay.
What I said is don't do it the OTP quote way, right?
Okay.
Which is the way that the Elixir community has fallen into, by and large.
Right. Do you believe that what Steven is doing is not the OTP way?
So there are documents, design principles behind OTP. There are a bunch of books. There's a great book by Francesco Cesarini and Steve Nunez on designing for scalability with Erlang and OTP. There are a bunch of things that go out and try and explore this specific question. But I want to point out that one thing you should not approach OTP with is the idea that there's always one specific answer for every problem. Call, especially overuse of call, isn't always a sign of like, oh, you have the wrong ratio or you're doing it more than not. It's the suitability of what works for you at that point in time. And what's nice about OTP's design is it gives you things to move to, options. You can switch things to cast, or you can make your calls semi-asynchronous because that from can be left to be responded to later, and then the caller can also change the way they do the call. And so you can make both sides behave a little bit differently. That flexibility is a little hard to see right away, but as you start building these experiences, you realize that you don't have to make these choices right away. And so really, if you have an idea of what will work for your code at that point in time, don't stress over making a call or a cast. Do the thing that fits your mental model. And then, as you revisit things, you'll learn and you'll become better at judging things ahead of time. And you'll start having a better intuition. Now, perhaps, you should revisit your code and think about it. But if it's not a problem now, don't force yourself. The idea is the flexibility is you can use cast later. You can change things. And the way module interfaces hide the GenServer calls, for an example, are done on purpose. So your call sites are just calling a function. They don't know if it's a cast or a call or doing something custom or it could be anything.
Does anybody have any specific objections or questions for the panel? Yes, right here.
Yeah, like hearing all this, call and cast. Like one of the nice things about a GenServer call is you are, behind the scenes, you're just abstracting away the callback from it, right? Like that's your GenServer call. And I think from the, as a programmer, I'm pretty stupid, right? Like, and I don't want to complicate my code. And if I want a response from something, right? And I have lots and lots of processes, let's say, running in my application. And one process is calling maybe GenServer that it's abstracted that there might be 50 of these GenServers running, right? Like, to me, that's the value of call. And then if you want to forget it and let the, pass a message and just let it cast, like that's the case to use cast. I find that the value of call is you get the benefit of of this concurrency without having to, and then you could wait as long as you want, have as long of a timeout as you want on that call. And if we all are doing cast, like we might as well just be JavaScript, just waiting for callbacks on everything.
If you do anything to your calls, instead of switching them to cast right away, timeouts. They're awesome. Do them everywhere.
But that's an interesting thing because you say that you abstracted all the way behind the module API, but that's not true because if it's asynchronous, then the actual structure of your entire application is going to be different, right? If you can assume that a call is synchronous, then it's going to go do this, get the result, now go do this, get the result. If instead it's asynchronous, then it's going to be far more like a stream-based approach. It's going to be far more event-driven. So you're going to be saying, initiate this, initiate that, now join the result, right? And that's very different in terms of application design. Now, to your point, I agree 100%, right? I'm not going to be saying, throw away your calls, right? And I'm never going to say to people, write code this way, not that way. What I am going to say, though, is that I think that going forward, the synchronous way of writing code is slowly dying in the same way that object orientation is gradually getting merged into the functional world. The functional world is gradually getting merged into the OO world, and that's all changing. And as we move away from a synchronous world, you bring up JavaScript, that's a really great example, right? Because if you were in JavaScript and you did all of your I/O using sync, right? File read sync or whatever it would be, people would laugh at you, right? Because you're not taking advantage of what's going on. Now, the trouble with JavaScript is that one of the rites of passage to becoming a JavaScript programmer is to write your own framework or write your own library. And so we have 8,000 different ways of handling that, right? We are not quite as wild as that, but we definitely need to come up with some solutions that allow us to write async code easily. Streams would have been that way if it wasn't for the fact that streams are currently pull, not push. If we could come up with some kind of push-based stream, then we have the convenience of async and we have programmability, which is as easy as doing call.
I want to ask about something I heard the economists say, which is that when a process is waiting for a response for a call is made from a process, it could lock up the beam. I think I heard that, and I'm not sure. Okay, so you're not saying that the beam processes are getting locked up?
No.
Okay. Sorry, I misheard.
Over here.
Just wondering if you had a comment about, like in the industry, it seems like OTP is more under fire from Docker and Kubernetes type worse solutions that maybe handle your swarm management a little, but like if you had any thought of that, it's almost like it's getting harder to go full OTP just because of the industry trends.
Yeah, but have you tried configuring a Kubernetes container with an Elixir application? Yeah, yeah. I don't think either is the solution. I think that I don't see anything wrong with containerization, but I think having say we were to unify supervision and allow it also to do that level of management, then that could actually take away a lot of that pain, but still leave us the benefits of containerization.
Hi. This is sort of a question about the world of OTP as, I guess, managed or controlled by Ericsson. Assuming that you want to make various changes, improvements, redesign things, is there a conflict between the direction you may want it to go? This isn't necessarily aimed at Dave, but it sort of addresses the possibilities. And the fact that Ericsson has this thing that they have control over. I may misunderstand the process, but has this thing that they have control over, and I guess they still want it to run on phone switches. And is that compatible with changing OTP to do something else?
So they have a lot of code, right? They have systems that work, and there are a lot of other companies that have systems that work, and they want them to keep working, right? Now, the idea that they could just stay with the version of Erlang and OTP that they have seems a little unfair. They want to keep upgrading and stick with the fresh system. So we have, sort of the conflict between legacy systems that have this high reliability and life cycle that's just in the matter of decades for system upgrades. Sometimes you might do small patches, but things just don't move fast. And so for a very long time, that was how Erlang evolved. Then later, through a bunch of efforts, the industrial user group was formed. And this was a a mix of companies that had various backgrounds, but some of them were startups. They wanted to move fast. They wanted to ship products now with things that had real issues. You had WhatsApp running, some of the highest scale chat servers, and they had custom patches that they wanted to upstream and say, look, this helps tremendously. Why don't we fix this issue? It took a long time, but as they got better with that conversation, things started moving, and then it became clear that there's yet another level of participation, not just these companies, but the community members themselves. And so I think a lot of the way we see Erlang and Elixir and the rest of the ecosystem evolve is going to rapidly change. What we see now is just the tip of where we're going to go and how OTP can change. What we want to say should belong and doesn't belong is now a conversation rather than just sort of, can we dodge these little dark corners and try and avoid issues.
Can we do one more question? Cool. I was wondering if those that know could speak a little more about partisan, given that like one of the things that's been touched on a number of times is that distributed Erlang clusters in general can scale to the level of dozens to low hundreds of nodes, but that there's research projects in the works to scale that much larger. And I was wondering if we could talk about what that looks like, and also if that kind of addresses maybe some of the scaling issues that David was talking about.
Yeah, I'll keep this short. Some of the conversation should probably be hallway after, but there is a lot of research into clustering, outside of even Erlang. This is just a topic people are trying to tackle in general. There are a lot of algorithms, and distributed systems has a lot of interesting stuff going on, but partisan is a really interesting effort, and what makes it interesting is that you can drop it into OTP systems. You can use it with GenServer. You don't need to change your GenServer code to make it work with partisan. And to the question of scaling and what works and what doesn't work with the built-in distribution, the distribution layer itself is improving. Things like head-of-line blocking with message chunking. If you don't know what that means, ask me after. All of those things are being addressed. And so one size may not fit all, but we see a bunch of different areas being improved. And so the future is pretty bright for that area. And fortunately, if you stick with the general OTP design principles, you should be able to leverage all of these things.
Okay, thank you very much to David and Brian, and thank you, Steven, for being my guinea pig over here.
Professional nodder.
Yeah. All right. Thanks very much. And thank you all.